You are looking for this paper in your notes. These are the ones we're putting in today. We have one paper that we're going to fold. It's not being cut. And so I did fold it so that it's going to look like this. Folding it so that this part right here is going to stick out. Like a little book. Here. I'm going to the center as much as I can. Can anybody do any more than that on it? Pascal's triangle. Does anybody know any more than that? Fine, I'll give you another hint then. You think you got something over there? Okay, I agree with that. I'll do the next level. What about the inside? No. Let's try. You need another hint? What? Ava? No. Lily? Okay, do the next level. Did you guys get the next level? What'd you get? Is that it? What else is there? Okay. Anything else? No? You guys don't have the pattern then, do you? Garrett? No? No? Nope. Try the next level. You've got to get it by now. What do you got, Ava? Keep going. Garrett. No. Yes. Keep going. Uh-huh. Uh-huh. Okay, next level. What's the pattern? Yes. Okay, give me the numbers then. And where are you getting your pattern from? 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. You're just adding the numbers above it. Right here, we had 1, 1, 1. It was 1 plus 1 is 2. Move down. 1 plus 2 is 3. 2 plus 1 is 3. You're looking at the two numbers above it. Oh, we're not done with it yet. That was the easy part. The first thing I'm going to say is that what we've just been doing, a sum of cubes, is not the same thing as a binomial being cubed. Those are not the same. Sum of cubes. Sum of cubes. This is two terms. It's called a binomial cubed. Not the same. We've been practicing the first one, sum and difference of cubes. The second one is where Pascal's triangle is used. I mean, we've been working with cubes like this, but what if I give it to the 5th power, to the 7th power? You don't want to do it the old algebra way. You want to know how to use Pascal's triangle. So I want to make sure I don't mess up Lily's notes. Okay, over here on the very first one, I'm going to say that this is x plus y to the 0 power. What's anything to the 0 power? 1. 1. Anything. This is both being raised to the 0 power. That's 1. The next one, x plus y to the 1 power. Let's write them all down. X plus y to the 2nd power. Notice that I'm going down each time on the level. And if you need the 7th or the 8th level, you would just keep going on the pattern. Okay, now open up your notebook to a blank page. We're going to practice some of these problems. We're not going to do a lot of these, but I wanted to show you something that was pretty cool. I mean, who the heck comes up with this stuff? Obviously, Pascal. But come on, what are they doing? Sitting around having their coffee thinking about this stuff? It's amazing that somebody could come up with this. Wait till you see it. I mean, I'm never going to come up with stuff like that. All right, so we are on the 4th level because it's raised to the 4th power. We're looking at the 4th level here. We're looking at these. These are all of the coefficients to the terms. There's going to be 1, 2, 3, 4, 5 terms. And those are the coefficients of the 5 terms. Okay, so the first time we do this, I'm going to be spacing them out. 1, 4, let's see. We're going to have a 1, and then I'm going to space it out. A 4, a 6, a 4. Did I do that right? 1, 4, 6, 4, 1. Those are the coefficients of the term. So we're on the 4th layer here. 1, 4, 6, 4, 1. Those are the coefficients of this polynomial that we're trying to expand into a polynomial. What degree is this problem? It's a degree 4. X to the 4th is the highest you're going to have. So you have x to the 4th, and then it's going down every term. X to the 4th, and it goes down to x cubed, x squared, x to the 1, and I'm going to say x to the 0. That's the A term. This is your B term. So the A term, the exponents are going down. The B term, the exponents are going up. So I would start with, I'm multiplying by 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th. And you could use parentheses there if you wanted to. I just used the dot. My coefficients are from Pascal's triangle. My A term starts with the degree that it is, and the x's are going down. The B term are going up, starting with 2 to the 0, 2 to the 1, 2 to the 2, 2 cubed, and 2 to the 4th. And then we simplify. And when it's a plus, it means they're all plus. And now I would just simplify my terms. What's 2 to the 0? 1 times x to the 4th is just x to the 4th. Two to the 1 is 2. 2 to the 1 is 2 times 4 times x cubed. 2 squared is 4 times 6 times x squared. 2 cubed is 8 times 4, 32x. And then 1 times x to the 0 is 1 times 2 to the 4th is 16. So x plus 2 to the 4th equals that. We'll try one more. Let's try 3x plus 1. And we don't have much time, otherwise I'd be going a lot higher. Let's do 4 again. So I would look at Pascal's triangle, and I would write down my coefficients for up to the 4th power. Now my A term is 3x. My B term is 1. What degree is this problem? It's a degree 4, so that means I'm going to have 3x to the 4th power, 3x to the 3rd power, 3x squared, 3x to the 1, 3x to the 0. Then I do my b term the same way. I am multiplying by 1, b is 1 to the 0, times 1 to the 1. Your exponents are going up. We know that the positive is going to be all plus. And there's one other thing that I should notice about exponents. What do you notice about your exponents? Brendan? Exactly. This is being raised to the 4th power. Look at all your exponents. 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3. They should add up to what the degree is here. Okay, and then you just simplify. 1 to the 0 is 1, times 1 is 1, so I don't need to worry about that, but 3x to the 4th. What is 3x to the 4th? Three times 3 is 9. 9 times 9 is 81. Don't forget to do 3 to the 4th power. 81 x to the 4th plus 3 cubed is, and then 27 times 4 is 108. Three squared is 9. We're just multiplying by 1 this whole time, so 9 times 6 is 54, x squared. And multiplying by 1, 3 to the 1, so 3 times 4 is 12x. And then plus 1.